Happy day, students. So today what we are going to do, in yesterday's class we found out that what is the VRMS, right, and the pressure exerted by the molecules on the gas. Okay, we'll continue with that. Today's class mostly will be based on the numericals based on this one and few more formulas. Okay, so first numerical we'll do. So what the question says, question is something like this. If the mass of each molecule of gas, okay, you note it. If the mass of each molecule of a gas is half and the speed is doubled, okay, mass of each molecule, so m dash is m by 2. Mass of each molecule is half, and what else? The speed is doubled. Find the ratio of initial and final pressure. Okay. Speed is doubled. Find the ratio of initial and final pressure. So first of all, let's remember that what is the pressure formula. So we got something like this, if you remember correctly, 1 by 3V mn VRMS square. This was the formula we got. Okay, he is not saying anything about the number of molecules. Let them be same. He didn't say anything about the volume. Right, he says what? Mass of the molecules will become half. So I am saying, let's say V initial by V final, 1 by 3V M initial, N same only. So okay, let's write MINI VI square by 1 by 3V M final, N final, and V final square. So this and this is cancelled. He didn't talk about number of molecules, so I am considering they are same. So this is also gone. And now what we have? Pi by Pf. Okay, Mi by Mf. Now he says Mf is Mi by 2. So Mi by 2. Okay. Then he says Vf is 2V. Okay. So Vi square 2Vi square. So this Mi gets cancelled. This 1 by 2 is going here. This will be 2. Okay. Then here Vi square cancelled, but this is 1 by 4. Our answer is 1 by 2. So pressure initial to pressure final ratio is 1 by 2. Right? Let's go for the second question then. What is the second question we want to do? Let's see. Okay. Second question says oxygen is filled in a closed metal jar. Okay, oxygen is filled in a closed metal jar. You note the question, okay? I'm not writing it on the board. Oxygen is filled in closed metal jar of volume 10 to the power minus 3 meter cube. Okay, so metal jar's volume is 10 to the power minus 3 meter cube. At a pressure of 1.5 atmospheric. Okay, pressure is 1.5 atmospheric. That means 1.5 into 10 to the power 5 Pascal. Okay, then, and temperature 400 Kelvin. Temperature given is 400 Kelvin. So fine. Okay. The jar has a small leak in it. The jar has a small leak in it. Let's say I am making this container as cuboidal, okay, cuboid structure container is there, which he is saying is jar, okay. Now in this one, here is a hole, okay, fine. The jar has a small leak in it. The atmospheric pressure, we all know, it's 1 atmospheric outside, okay. Then atmospheric temperature is 300 Kelvin, outside temperature is 300 Kelvin, fine, no issues with that either. Find the mass of the gas that leaks out by the time the pressure and the temperature inside and the jar become same. Okay, first thing is that only. Now inside, if there is a gas and there is some pressure and there is some temperature. So if there is a leak developed, what will happen? We all know that gas moves from high pressure to low pressure. So obviously gas will start moving outside. and it will keep on moving till what point? The pressure at both ends becomes equal. If the pressure at both ends is not equal, still some higher pressure is there inside, gas keeps on leaking. Okay? So he wants that how much mass of the gas is leaked actually. That's what he wants to find. I said, okay, fine. So when you see his mass, then what we have to do? First of all, let's find out how much is the mass inside. How to find? Number of moles. Number of moles. He said already oxygen is there. So if I know the number of moles, I'll find out how much is the mass. Very easy for me. Right? So we'll go for number of moles first. So first of all, let's find out how much is the initial number of moles. We'll say PV equal to nRT. Everything is given, you see. Volume is given, P is given, T is given. So I can find initial number of moles. What is that? PV by RT. Okay, P is what? 1.5 into 10 to the power 5. Volume is 10 to the power minus 3. R value 8.314. And temperature is 400 Kelvin. Finally, what is going to happen? He said that this should be the pressure and this should be the temperature. So final also we'll find. Okay, and final. Formula is same, PV by nRT. So P is what now? 1 atmospheric given. Right? V is same, container's volume. You can say that why V is same, because some has leaked out. I told you that no matter, irrespective of how much mass of the gas is, it always occupies the entire volume. Okay, we discussed it. If you remember, I asked you about LPG, 14 kg, 2 kg, right? 14 kg also occupies full volume of the gas cylinder, and 2 kg of the same LPG also occupies entire volume of the cylinder. Okay, that's the characteristic of the gas. So here also, even though some mass has gone outside, but the total volume occupied by the gas will be full only. So 1 atmospheric into volume by R 8.314 into temperature is 300. Okay, now number of moles gone outside, delta N, we want Ni minus Nf. You see that what we can take out immediately. Okay, 10 to the power 5, 10 to the power minus 3, this is outside. Actually, this is 10. Okay, let's solve. Okay. 1.5 into 10 to the power 2 by 8.314 into 400. 10 to the power 2, this is also cancelled. So 1.5 by 8.31 into 4. Here, 1 into 10 to the power 2 by 8.314 into 300. Again, this and this gets cancelled. Okay, so what we have, this 8.314, that is R only is common. So 1 by 8.314 outside, then you have 1.5 by 4 minus 1 by 3. This is delta N, number of moles that has gone outside. Okay, but what the question was asking? Mass, I think. What was the question? The gas that, find the mass of the gas that leaks out. Find the mass of the gas. So, okay, fine. So, this is the number of moles gone outside. So, mass of the gas which leaks out. Mass of gas leaked out will be what? This is the number of moles which went out into molecular mass. Okay, so here is what? This is 8.314. Then I am taking LCM. LCM will come 12. Right, 12. Then 4.5. 4.5, and here will be 4. So it will come as 0.5 only. It's LCM if you take 1 by 8.314. Okay. Here LCM will be 12. So 4 3 is 12. 3 into 1.5, 4.5, and 3 4 is. So something like this will be. So 0.5 I have written 8.314 into 12 into. If suppose I want to calculate it in gram, I will multiply directly with 32. So 32 will give me the answer. I hope this is visible to you. Let's see. I'll tilt it a little, okay. Now it's fine, I think. I hope. Okay, see then what I have done over here, okay. This I told you already, PV by RT. So you can see the calculation now clearly, okay. So 0.5 into this thing into mass, 32 gram. If suppose we want answer in terms of gram only. So what we can do, this is 4 3 ja, this is 4 8 ja, this is 8 into 0.5, that is 4 by 3R. Now 3R means that this is 25. Okay, these many gram. 4 by 25 gram will be going out. Okay, so this is the answer of the question. Okay, let's go for another question then. Okay, let's go for the another question. What it says. Okay, it's a different type of question altogether. Find the coefficient of volume expansion for an ideal gas at constant pressure. Okay, find the coefficient of volume expansion of the gas at constant pressure. Now, volume coefficient. Now, what we know about volume coefficient is delta V equal to V gamma delta T. Okay, so gamma basically is what? If I take this in differentiable form, then I can write this as dV by dt to 1 by V. This is gamma. This gamma we have to find, volume coefficient of the gas at constant pressure. What to do? For the gas we have to do, what relation we have? We will say that okay, we have a relation called PV equal to nRT. This is ideal gas equation. Right? If I am going to differentiate it with respect to temperature, see, so here P is constant, okay, so differentiating with respect to temperature gives us dV by dt, and here nR, and differentiation of T is 1. What I got here is dV by dt. I also wanted dV by dt. So dV by dt's value that I got is nR by P. But to go to the gamma, I have to multiply here with V also. So okay, let's multiply here with V. Now this is gamma. So gamma actually is nR by PV. Right? But you see that PV basically is nRT. So that means nR by nRT. This gets cancelled. So it's 1 by T. So gamma at constant pressure is equal to what? 1 by T. Inverse of absolute temperature of the gas. Okay? You can note it, you can pause it and you can note it, right? Okay. Let's move on to something else now. Now, as I told you, Vrms is one of the velocity which was calculated while doing the practical or while doing the observation. The scientists also thought about some other velocities because particles were going with all the different velocities in random direction. So first they thought that okay, let's talk about average velocity. Okay, so average velocity also they calculated, but that is not referred in the same way as RMS. RMS is taken everywhere. Whenever we talk about the velocity of the particles, we talk about RMS only. But still, there may be a question asked like average speed. So what that is? So average speed basically means is, okay, addition of the particle speed, all the particles, whatever number of particles are there. Suppose n particles are, divide by n. This is called average speed. Okay, and they gave us value also. They calculated it. It came out somewhere around root over nRT by m pi. Root over nRT by m pi. This is for mole. Okay. Whenever I am writing capital M, it's for mole. For molecule, we write small m. And then we don't write R over there. We write K, Boltzmann constant. We'll discuss it some other time. Okay, so V equal to root over 8 RT by N pi. What kind of questions can be there on this particular formula? Okay, simple calculation based questions will be there, nothing more. Okay, so let's see if I give you one of the question on that one. Find the average speed of nitrogen at 27 degrees centigrade. The similar thing what we did in RMS also. So what is he asking? Find average speed of nitrogen at 27 degrees centigrade. Now average speed formula we have already. Let's put it. So 8 into 8.314. 27 degrees centigrade means 300 Kelvin. Always and always remember that temperature we have to write in Kelvin. Never ever in degrees centigrade. Okay. So nitrogen I am considering it to be N2. I have written N2. So its mass is 28 into 10 to the power minus 3 into 22 by 7. That's 5. We can calculate that. This is 4. Then this is 2. Okay, then what else we can do? So this is 2 into 8.314 into 300 by 22, and here again 10 to the power 3. Right? So this we can write as 11. More than that, anything we can do? Roughly, okay, say 11, so not like this, 8.314 by 11, right? What I am doing is, this 1000 will adjust in this one. Let's write it as 8314 by 11 into 300, okay? Now I am going to divide this, 11 7 jai here, okay? 7 then 6 will come over here, then 11 5 ja, then 6 will come over here. So roughly I am writing this is 756. So this is root over 756 into 300, which we can write as 7.56 into 3 into 10 to the power 4. Okay, take this 10 to the power 4 outside. What will come? 100? 100 into 7.56. Now 7.56 means somewhere around 2.7, 2.8, somewhere like that. Okay. So approx answer is 280 meter per second. Approximately our answer comes out to be 280 meter per second. So these kinds of questions they will be asking you on what? On average speed. Root mean square speed, we have already got the formula. But what is its meaning exactly? That we will see now. Okay? And few more questions also we will do on that. Okay? So VRMS basically is what? VRMS. Root means square. Root mean square. Now this root mean square again you are going to see in another chapter, that is in 12th class, that we talk about alternating current. There also you will be getting IRMS, currents value. Okay, what basically is this? So VRMS basically is root over, as the question is, root of mean of squares. Root of mean of squares. So squares here means V1 square. This is the particle's velocity, all the particles. Mean of squares. What was average? V1 plus V2 plus V3 plus by n. Here is root mean square. That means root over V1 square plus V2 square plus V3 square plus n particles square by total number of particles n. Okay, this is called root. And its value we already have calculated. What? Root over 3RT by m, or root over 3PV by What it was? M. Right? This end is different, this end is different. Right? This is mass of the gas, this is molecular mass of the gas. And if we talk about kinetic energy, what is kinetic energy? Now see that. This is mass of the gas, no? Vrms. So Vrms square equal to 3 PV by M. MV square, MV RMS square, okay, equal to 3 PV. Now kinetic energy means 1 by 2, so here also 1 by 2. So kinetic energy of the gas, you can say is 3 PV by 2, okay, 3 PV by 2 or 3 by 2 kT, okay, 3 by 2 kT, that is the kinetic energy of the gas. Alright, so this also is very important formula. Okay, right, so let's see, suppose we are going to solve few questions on that one. How will those be? Few questions already we have solved. A few more questions if you want to solve on root mean square speed. How these questions will be? Just see them. Suppose a question is given, the molecule of a given mass of a gas have Vrms. The molecules of a given mass of a gas have RMS speed 100 meter per second. Okay. Molecules of a given mass of gas have root mean square speed of 100 meter per second at 27 degrees centigrade at 1 atmospheric pressure at 180. Okay. Then what will be the RMS speed of the molecules of the gas at 127 degrees centigrade at 2 atmospheric pressure? What will be Vrms at 127 degrees centigrade at 280. Okay, fine. Now we know the formula of Vrms as root over 3 RT by M or 3 PV by M. Now in this you see what is given to you, temperature is given and pressure is given. But in this one we don't have any formula in that. What to do? Right? Temperature is changing and pressure is changing. So what we can do is, let's have the ratio. This is okay. So let's say Vrms 1 by Vrms 2. I'm going for this formula. Here the pressure is there. So 3 P1 V1. But the gas is same only. So mass I am taking same. Here also 3 P2 V2 by M. This is in square root. Fine. And 3 also cancel. Root over P1 V1 by root over P2 V2. In that one P1 and P2 I know. So there is a problem with the volume. What is the volume in this one? Right? So volume we have to check. What we can do with the volume? Okay. Now since we have taken mass of the gas is same, so I am considering that number of moles also will be same only. In both the cases, then only we can say mass of the gas is same, right? So if the number of moles are same, can I say P1 V1 by T1 is equal to P2 V2 by T2? This is the number of moles only, right? So pressure here is 1 atmospheric. So 1 into 10 to the power 5. V1 I don't know. Temperature is given 27, that means 300 Kelvin. Here P2 is 2 atmospheric, that is 2 into 10 to the power 5. V2 we don't know. Temperature is given 127, that is 400 Kelvin. So 10 to the power 5, 10 to the power 5 cancel. This and this cancel here. Now what we got? V1 by V2 we got as 6 by 4. That means 3 by 2. Is it okay over here? Yes, fine. So let's bring it over here. This is P1 by P2. Now P1 is 1 atmospheric. You can write 1 only. P2 is 2 atmospheric. That's 2 only. Then V1 by V2 is 3 by 2. So what we are getting as VRMS 1 by VRMS 2, it's root over 3 by 2. I am getting the answer as root over 3 by 2. So VRMS value actually V1 is given as 100. So 100 by VRMS 2. So VRMS 2 value is what? 200 by root 3. VRMS 2. What is coming? 200 by root 3. That's our answer. That's a good question, which is not directly based on the formula, like root 3 RT by MR given, T given, M given. Slightly different kind of approach is required to solve this. Okay? So this is one of the questions. Other than these two, there is one more kind of a velocity or speed. That's called most probable. And what is that? That is root over 2 RT by M. Okay? Most probable speed. Normally for calculation we take VRMS only everywhere. Most probable means what? Most probable means that particles are found to have this velocity more often than not. That's why it's called most probable velocity. Okay? Most probable velocity. So what is that? VMP. Its formula is root over 2RT by M. Okay, root over 2RT by M. Now, at certain time, again this, you know that how to do the questions. If you can do VRMS problems, you can definitely do research. Sometimes they ask you what is the ratio of V average, VRMS and VMP. No problem in that one, we can find. This is what root 8RT by M pi. This is root 3RT by M. And this one is root over 2RT by M. RT cancelled. M cancelled. So what is the ratio? You can see that this is 8 by pi is to root 3 is to root 2. Okay? So that's all for today. Okay? Then again, we'll be seeing in the next class. Okay? Bye for now.